In this video, we're going to look at dictionaries. Dictionaries are collections in Python, just like lists, except they're a bit more powerful and they're very useful for us to understand, and they will also help us with the data analysis libraries that we're going to be covering shortly. So let's first take a look at the differences between the two, the list versus dictionaries. So if we think of a list, let's say we call our list nums, and say we have a list of 4 integers, some arbitrary values. Now, when we define a list like this, each element is associated with an index starting at 0, so the index is an integer, and we could think of the index as the position in the list. So index corresponds to a position in the list. Now, so this is what lists are. This is how they work. Now, on the other hand, with a dictionary, the indices of a dictionary are arbitrary, so they could be any value, such as a string or an integer that we ourselves define. So let's take a look at an example. So let's suppose I want to keep track of the population of some cities. So I'm going to call that population. I'm going to call my dictionary population. And now, instead of using an integer as the index, I'm going to use the name of the city as the index into the dictionary. So here I'm going to define 4 elements in my dictionary for 4 cities: Chicago, New York City, LA, and Houston. Now, because these indices are not positional, just like they are in the list, these are referred to as keys. So these are the keys of the dictionary, and then you could think of doing a lookup by the key. Now, in each element in the dictionary, I'm going to store the population in millions of inhabitants, and these are 2008 figures. So here we are. Now, each element in the dictionary we can think of as a key value pair. So in this case, this is the key and the corresponding value. So the definition of a dictionary is that it's a collection of key value pairs. Now, another point about dictionaries, which we're not really going to get into, but it's something to keep in mind. So with a list, the elements are ordered, right? So the way you specify them is the order in which they're in. With a dictionary, the way the elements are stored in the list in the dictionary is arbitrary. So even though I add elements to my dictionary in a given order, there is no guarantee that this is the order in which they're stored. So dictionary is unordered. Okay, now this is good to keep in mind, because there are times you're gonna get results that look wrong, but they're just simply out of order because that's how a dictionary is defined. Okay, so now how do we go about defining a dictionary? What is the syntax for doing that? Well, so turns out it's actually pretty straightforward. So instead of using the square bracket notation, as we do in a list, we're going to use the curly braces, and that's what tells us it's a dictionary. And the elements in the dictionary are separated by commas. And then here are the key value pairs. So the key value pairs are separated by colons. So, and then the first value is the key, and what's after the colon is the value. So this is how this is one way of going about defining dictionary. So let's execute this. So here we are after defining the dictionary. If I were to print it out, it shows me the collection of the key value pairs. Okay, and if I want to just look at the value of a given city, the population of a given city, then I'm going to use the square bracket notation, and between the square brackets I'm going to put the key, which is the name of the city. And here if I'm to execute this, it's actually gonna look up, it's gonna find Chicago, and output the value corresponding to Chicago, which is 2.7. Okay, so moving on. So let's look at how we could add and delete elements from the dictionary. So first, to add an element, well, we simply, also using the square bracket notation, I'm going to specify the key. Now, because this key does not exist in the dictionary, it's going to actually add it. So in this case, I'm defining a new entry in the dictionary for Philadelphia, and Philadelphia's population I'm defining to be 1.6 million. So if I were to execute this, it's gonna output 1.6. Now, to delete an entry from the dictionary, I can use the delete operator. So in this case, I'm deleting the entry for Chicago. So after deleting it, if I attempt to print it, I'm gonna get an error, an exception, specifically, which is something we'd expect. So it says it cannot find the key. That's the key error, Chicago. Okay, now oftentimes it's useful to be able to determine if a key is already in the dictionary. And to do that, turns out there's a very intuitive operator called the in operator. So we're going to use the in operator to do that. So let's take a look what that looks like. So here's an example. So here, given a city name from the user, what I'm going to do is determine if that city is in my dictionary using the in operator over here. So if it is in the dictionary, I'm going to output its population, and otherwise I'm just going to say there's no record found. Okay, so let's try this out. Let's try New York City, and it did find the population, 8.6, and if I were to run this for Dallas, which I know is not there, it's going to say there's no record found for Dallas, so it executed the else clause. Okay, another very useful operation that we often want to apply to dictionaries is to iterate through the elements in the dictionary. So to iterate through the elements, we could use the keys method. So keys, when we call keys on a dictionary, it gives us back a collection of all the keys. So, and then in our case, the keys are the city names. So here I'm going to iterate through them, one city at a time, and I'm going to do some formatted output. If you remember the format function, these are placeholders for the variables that come later. So the first set of curly braces corresponds to city, and the second one corresponds to the population of the city. So these don't confuse those with this curly braces for dictionary. They're completely different. So let's execute this, and here we are. It's going to iterate through all of the contents of the dictionary. Now, if you notice, the order in which these are displayed is not how we created them. Well, actually, in fact, that it just happens that that's not true. Okay, that is true. So I was trying to make a point about dictionary being unordered, but in this case, it just happened that the way we define the dictionary, the order is still maintained. Anyway, okay, so moving on. Another useful operation is to be able to just extract the keys from a dictionary, or just the values. So this might come in handy at some point, and we want to be able to extract the keys or the values as lists. So I'm going to show you how to do that. So if to extract the keys of a dictionary, I'm going to use the keys method, and to extract the values, it's the values method, and then to treat that, to convert that to a list, I'm gonna call the list operation. I don't want to get into the details of what list exactly is, but it's essentially converting the collection of keys into a list. So let's run this. So here I'm going to output two lists, one of the keys and one of the populations. So these are the keys, and here I have the population. Okay, so that could come in handy at some point, and it's good to just see an example of how to go about it. Now, just to conclude, so dictionary is just a collection of key-value pairs, and it's good to remember that a dictionary is unordered, and the key of a dictionary on which we do a lookup is an arbitrary value that we specify. It could be string, could be an integer, etc. And then finally, this is something to know, although we can't get into it in any details, is that dictionaries are very, very efficient structures. So they allow us to do lookups. So even if you have a massive dictionary of a billion elements, we could do lookup in a dictionary very, very quickly. So that's why that's one of the reasons they're quite powerful. Okay, and then with that, we conclude our discussion of dictionaries. So thank you for listening.